We're going to be working with function notation. And when we talk about function notation, we're talking about f at x. And we spoke about this symbol on the first day. Essentially, f at x is our equivalent of the y variable. The reason we write it like this is because we need to be able to distinguish between different equations. And sometimes we need to be able to represent two equations very simply instead of just writing them. And you'll see what I mean in the fourth example when I'm talking about that. So for instance, f at x here. What this is saying is the function, which is here, when we have the variable x is equal to this equation. So our variable is x in this equation. They may ask us in our question for f at, let's say, value of 2. And what that means is they want us to replace all of the x variables with the number 2 and then carry out the equation. So what is this function when x is equal to 2? That's how they would represent it. Instead of writing it in a sentence, they just do it with a couple symbols. So that means we now have 3 times 2 to the power of 2 minus 4 times 2 plus 10. According to BEDMAS, we would do exponents first. 2 squared is 4. And then I have to multiply it by 3. So I'm going to do this all in one step. What is 4 by 3? 12. Great. 4 times 2 gives us, yeah, that's right, because it's negative 4, so it becomes negative 8, and then plus 10. 12 minus 8? plus 10?
14.
So, when this function, when the variable is 2, this function is equal to 14. That's what the question's asking when they give it to us like that. Straightforward?
Yes.
Okay. We'll do another one a little more difficult. Let's talk about the function when it's half. Okay. Same idea. We have to keep the original function we had, so it's 3, and instead we replace x with
Half.
half.
Or 0.5.
Or 0.5. So whatever you feel more comfortable working with. I work much better personally with fractions, so I'm going to keep this in fractions. But if you want to change it to a decimal, it's the exact same thing. 1/2 squared means 1/2 times 1/2, which will give me 3 times a quarter, because I know my multiplying rules for fractions. Top by top, bottom by the bottom. Here I'm going to get 4 over 2 when I multiply those values.
Decimal?
I'll show you what that is. This will be 0.5 in a decimal. And then this ends up being 3 over 4 when I multiply. Minus 4 over 2 is actually the value of 2, so minus 2 plus 10. Okay. I'm going to put these all into the denominator of 4. So 3 over 4 minus 8 over 4 plus 40 over 4. Now, I can add and subtract. So hopefully you remember your fraction rules. If you don't, you might have to go back to see how I did that. I'm going to subtract these. This will give me negative 5 over 4 plus 40 over 4, which will give me positive 35 over 4. And that's an acceptable answer. I'm not sure exactly what that is in the decimal, but that solves what they've asked us. Okay. Next we have the function g at x. And if you notice, when I do dual page here, g at x is different from f at x. And that's our idea of function notation. I'm just using a different letter to represent a different equation, but they both have the same variable x. Okay? And this is why we write things in different notation, or in function notation. Now in this example, it may look complicated, but this one's very, very straightforward. All I have to do is equate what's in here. So this becomes g at, what is 5 minus 1? 4. And then it becomes very straightforward. I'm just plugging in the value of 4. Okay? So I would just plug 4 into this. A very simple equation. I'm actually not going to work it out because in the next one will take us a little more time. The next example, we'll call this example 4. I want to find f at 1 minus g at 4. So we'll use that 4. So what I've done here is we're talking about two different functions. We use f to represent the very first function we work with, and g to represent the function above. So I'm going to write these functions above so that we can see what we're referring to. In this one, g at x is equal to 5x squared plus x minus 4. We'll keep that in mind. And in the other one, it's 3x squared minus 4x plus 10. So here we have x. 3x squared minus 4x, is that right?
Yeah.
Plus 10. So if you notice, two very different functions. And what they want us to do is in this function, plug in the value of 1 and get a number. In this function, plug in the value of 4 and get a number. And then from those two numbers, we subtract the values. Okay, so there's a bit of work to this one. So let's write them out. We'll put them in different colors. I'll do f at x in blue. So f at 1 is equal to 3 times 1 squared minus 4 times 1 plus 10. So this is our f at 1. Green's a good one. We're going to subtract our g at x. Well, g at x is g at 4. So that's 5 times 4 squared plus 4 minus 4. So if you notice, I've replaced f at x with one equation and g at x with another. Next, all we have to do is really equate what we have. So let's try to do this out loud. 1 squared is times 3.
3.
Negative 4 times 1.
4. Or negative 4.
And then plus 10. The first part narrowed down. Second part. This is a little more difficult. You might need calculators for this.
8.
What is 4 squared?
8.
16 times 5. 80. Very good. Still going to be plus 4 and then
It's
minus.
going to be 80. That's 80.
Good. So now that we've done that, let's add and subtract. 3 minus 4 is
Negative 1.
negative 1 plus 10.
9.
Subtract 80 plus 4 minus 4.
80.
Yes, exactly. Those cancel out. Subtract 80. So there's positive 9, subtract 80,
71.
negative 71. And that would be our answer
How is it? Oh, it is.
in this question. Let's take a look at these dual pages. There's still one more I want to go. Okay, our last example, we've replaced x with
4x squared.
a number that still has the variable x in it. So let's get our g at x equation, which I believe was g at x was equal to 5x squared plus x minus 4. Right? What they want us to do now is they want us to replace the x's with
4.
what we have in there. Okay? So, let's replace that. G at 4x squared is equal to 5. 4x squared squared plus 4x squared minus 4. So, in this first one here, I have to square that. In other words, this is the base times the base. So we multiply the base by itself. We can do that on the side. 4x squared times 4x squared. So, we multiply the coefficients. What's 4 times 4?
15.
And then I have x squared times x squared. I just add exponents. X to the power of 4. That's right. So we have x, or 16, x to the power of 4. So 5 times 16x to the power of 4 plus 4x squared minus 4. Now over here we just have to multiply the coefficients by each other. 5 times 16, anyone remember? 80. 80x to the power of 4 plus 4x squared minus 4. That's as simple as we can go. So our answer is just another equation in this sense. Okay, we were unable to simplify that variable. That's as far as we go. That's all we needed to do for that question.
Really?